carrying out an experiment and for you to observe and make your conclusion or inference in practical under solubility. In the condition where you are just to observe and make inference if a given substance dissolves in another or not. If that is just what you are expected to do, then whenever you add the substance to another and you try to mix two of them, three conditions are possible. Either of them must occur. It's either that those two substances, the one you are adding with the solute, is soluble in the solvent. In that case, say is soluble. When you add the solute to the solvent and you discover that the solute, in the case where it is solid and the solvent liquid you add, and the solid is no longer seen, the solid dissolved, or in common word, the solid has melted, though it's not scientifically correct to say melts, but dissolved is the correct word. It has dissolved. You are not seeing any particle of the solute, which was solid, added to the solvent. Then we say in that condition, that solute, that solid is soluble in that solvent. So you report with a capital letter S. So this can be used to note if it is soluble. Then another condition that is also possible when you add a solute to a solvent, another condition is can be insoluble. It can be insoluble. Insoluble in that condition, when you added the solute into the solvent, the solute you added is still intact, is still in the solvent. After several attempts to dissolve it, after several attempts to mix it, you still discover that the solute is still intact in the solvent. In that case, we say that substance is insoluble in the solvent. So we can present it with capital letter I. We can present it with capital letter I. Now, there are cases where, which I have demonstrated, where when the solute is added to the solvent, now you no longer see the particles in solid liquid interaction, but it appears as if it has dissolved, but the solution becomes milky or cloudy. It's not clear, like when we judge the case of when it is soluble, where true solution is found. In this a case where particles are not there and also the solution is not clear but it's cloudy, in that case we say it's sparingly soluble or slightly soluble. So we say sparingly soluble. We can represent this with X. You can represent this with X. So when you are carrying out the experiment and you are instructed to judge, you can in such form use SP to represent sparingly soluble. and alcohol is mixed and it forms a cloudy solution that is sparingly soluble. I will present it with SP. That's what you are expected to do. Welcome to the Chemtech. Now in this video, I want to talk about solubility. Now, solubility, when we talk about solubility of solvents, we are talking about two substances. One can be solid, the other can be liquid. Another time, both of them can be liquid. So it can be liquid, it can be solid liquid. It can also be liquid gas or gas liquid. Now, in this discussion or demonstration, I will narrow myself to liquid and solid liquid solubilities. Now, when we talk about solubility, we are talking about how a given substance is being accommodated in another. Take note, a given substance is being accommodated in another. Now, in solubility, one substance dissolves in another. That is what we call solubility. Now, we can find out what quantity of a substance can be accommodated in a given volume of another substance. Now, for example, it is understood and agreed or experienced that salt is soluble in water. So now, what quantity of salt can be accommodated by a given volume of water is what we need to find out. The reason why we say salt is soluble in water is because we discover that the molecules of water accommodate the particles of salt when it is being dissolved. That's why we say it is soluble. Now for salt, 100 milliliters of water has a particular or a specific amount of salt that can be dissolved in 100 milliliters of water. Once you introduce more than that quantity, then you will now have some particles undissolved as residue. As a result, you have a saturated solution. So, no matter how soluble a given substance is, in another, there is an extent, there is a quantity, an amount it can accommodate, an amount it can dissolve. So, solubility must have a specific amount of substance that can be dissolved in that volume of liquids. Now, for salts, it's about 30 grams of salt, table salt particular, or sodium chloride can dissolve in 100 milliliters of water. But if you introduce like 40 grams of table salt into 100 milliliters of water, you are going to have a saturated salt water solution where you have some particles of salt undissolved. Now, there is a principle in solubility. The principle is this: like dissolves like. Like dissolves like. What does it mean? Like dissolves like. Like dissolves like. Now, what does it mean? Substances that are similar can dissolve in one another. Substances that are similar can dissolve in one another. What is the similarity? You can use polarity to compare the similarity. It then means that polar substances dissolve in polar substances. Non-polar substances can be dissolved in non-polar substances. It then means that a polar substance cannot be dissolved in non-polar substance. In this video, we are going to demonstrate at what point we say a given substance is soluble in another, at what point a given substance is insoluble. Now, when you introduce solid into liquid, and the solid particles you introduce into the liquid is not seen, disappears, then we refer to that as being soluble. But when you introduce solid particles into a liquid and the solid particles remain undissolved, we say in that case it is insoluble. The same thing for liquid-liquid interaction. If you introduce a given volume of liquid into another and you don't see, you cannot identify the difference, you cannot identify the separation, and they are probably mixed together. As a result, you see it as true solution, as one solution, and there is no separation. It means that substance you introduce is soluble in the other solution, substance you introduce it to. So that is liquid. But if you introduce a given liquid into another and make some efforts to mix it together by shaking or you acetate, and after that is done, you leave it for a while, you discover, if you see that the two liquids separates again and have a boundary, one at the upper layer and the other the lower layer, it then means that those two liquids are immiscible. They are not soluble in each other. But the principle behind it is the substances that are similar in polarity will dissolve in one another. So we can go into demonstration to buttress this principle of solubility,
like dissolves like.
LEL. Now, I will begin with solid in liquid interaction. Solid in liquid interaction, in other or we can say solid liquid interaction. Solid liquid interaction. Now I have a salt crystals, some salt crystals here, some salt crystals here. Now I will introduce it to a liquid and to find out whether it is soluble or not. Now, let's find out. Now, I have this is oil. It's an organic substance. And organic substances are most times non-polar. I'm going to introduce salt, which is inorganic substance, which is polar. I'm going to introduce and you'll discover what's happened, whether the polar salt is salt which is polar will be dissolved in oil which is non-polar. Now, the salt in water has dissolved, completely dissolved. Why? Because salt is polar, water is also polar. Now you understand?
Like dissolves like.
Now look at this. It cannot salt in water. Oil is not dissolved because of that same principle. Now we can proceed to a liquid-liquid interaction. Liquid-liquid interaction. Now, liquid-liquid interaction. We have said before time that if you have a given volume of liquid to another, and after you have agitated, you have shaped, try to mix them, and you leave it for a while, and if you discover that a boundary is formed, it forms upper and lower layer, two distinct layers, it means those two substances are immiscible. You can say they are insoluble. Now, I will now have tried to mix oil in water. This is water. This is water. Now, I would like to add oil into it. And I shake. Wait for a while. You discover that the oil is separating from the water. In this separation, if you wait a while, you're going to see the two distinct layers. Now, you are seeing the boundary around here. Now the upper layer is the oil, while the lower layer is the water. Now, why water is blue and oil is at the top? It's because of difference in density. Water is more dense than the oil, hence the oil floats while water sinks. So if you introduce oil in water, the oil will float on water. If you introduce water into oil, the water will sink in the oil because of difference in density, thickness of that. I think now the boundary is clearer than before because it has stayed for a while. This is the boundary. Here is the oil. Here is the water. This is liquid-liquid interaction that is immiscible. Now, because of difference in polarity, what I mean, oil is non-polar, water is polar. Hence, they cannot mix because they are not alike. Like dissolve like. That is the principle. Now, we can have a liquid-liquid interaction where they are mixable, It then means that they have resemblance in polarity. If they don't have resemblance in polarity, it cannot mix. So I have alcohol here, in this case ethanol. I have some ethanol here. Let me take more ethanol. Then let me add some water. shake several times, try to observe. Now you discover that it is miscible. So water and alcohol are miscible. Why? Because water is polar, alcohol is also polar. But not all kinds of alcohol can be. The extent of polarity in alcohol, different alcohol varies. Now, alcohol is a compound that has OH group attached to a carbon chain. So, for ethanol or methanol or propanol, where the carbon atoms are 1, 2, and 3, now can be soluble in polar liquids like water, because the polarity is still high because it has a lower carbon chain, so it can be dissolved in water. So you can see a clear solution formed. There is no boundary. Two liquid mixed, ethanol and water, clear solution. This is what we call liquid-liquid interaction miscible. It forms a clear solution. Now you compare both the solution before, the clarity of the solution before, and after mixture. You consider if it forms a clear solution, it means you see it is very transparent. It means it is completely or very miscible. Now this is a liquid-liquid interaction of alcohol and water because of their similarity in polarity. Now let me also look at I've talked about alcohol I've talked about oil in water. I've talked about alcohol in water. Now how about a case where a liquid is mixed with another liquid and there is no boundary formed, and yet it does not form a clear solution? What do we classify that mixture or that interaction? We can say that is sparingly soluble, or slightly soluble. Now, we can take that oil in alcohol mixture. Now, oil is non-polar. Alcohol is polar, but yet organic. So the organic part, the non-polar part of the alcohol would like to dissolve in oil because oil is an organic substance. But the solution, but this solution is cloudy. Is what we call sparingly soluble. Now let's look at a soluble soluble condition, then sparingly soluble condition, and insoluble condition. Now you can see these three conditions. This is alcohol in water, soluble. You see a clear solution. There is no boundary formed, and it's not cloudy, so it's soluble. Now, in this condition, middle condition, we have a condition that we are not seeing any distinct boundary, no separation, but it's cloudy. We refer to this as sparingly soluble condition. And then here we have two boundaries formed. So we call this one insoluble or immiscible condition. Now you can observe three conditions. The middle one is sparingly soluble. My right hand side is immiscible insoluble, and my left hand side solution is soluble or miscible condition. So you can see the difference. Now, it's very, very important that students should understand no matter how soluble a substance is in another, if you had excess of it, it would appear as if it is insoluble. Why? Because we will see some remnants of the solid remaining in that solution. Once you have added more than what that volume of liquid can accommodate, now it will reject or it will refuse to accommodate the excess you have added. So the excess will settle down in that solution as precipitate or residue, and it will not dissolve. So you shouldn't refer to that condition as insoluble. It is soluble, but you added excess of the solutes. That's why it's appearing. Those particles are still found in that mixture. So in carrying out solubility tests, as in just to test if a given substance is dissolved in another, or a given liquid is miscible in another, just add a very little. Don't add much, so that you observe to know if that little you added dissolved or not. So solubility in a common term is the ability of solid to disappear in a liquid, or the ability of the liquid to disappear in another liquid, where you cannot differentiate what you added from what you added that substance to. That is solubility. So please, dear, I would like to drop now. This is bigger boiling tube solvents plus solutes. Solution is equal to solvent plus solute. Now for a solution to be formed, it means you must have solvents and solutes. Now, the solute is added to the solvents and the solvent dissolves the solute. So you now have solution. Now, for you to know which of the two substances, which of them is solvent, which of them is solute, that forms a solution, the one with greater quantity will be the solvent, while the one with less quantity can be referred to as solute. The factor for solubility is their polarity. If they have resemblance in polarity, then they can dissolve in each other. But if they don't have resemblance in polarity, they cannot dissolve one another or each other. It's not possible. So that's why life dissolves life. They must have resemblance in polarity, closeness in polarity. They must be alike in polarity, or they must be alike in structure. For us to have a solution, when a substance is dissolved in another, what actually happened? Yes, what actually happened? You see salt, which is in crystal state, added to water, the body of water, the volume of water. You see the salt crystals disappear. You don't see salt at all. And if you call somebody who was not there when you added the salt to find out if there is salt in that water, the person will say no. You can no longer see salt. Why? Salt in crystal, salt in solid is in crystal state. When it is dissolved, it's ionized and it exists in ionic state. As a result, you can no longer see the particles of salt because the salt in the ionic state or the ions in the salt in solution is very, very fine, very, very little that you cannot see because they are very small that ordinary eye cannot see. That is why you see the solid disappear in liquid when it is dissolved. The same thing for sugar with sucrose dissolved in water or in alcohol. What actually happened is this. In that case, sugar being organic is not ionized, but it's molecularized. It exists now in molecular state. jam together. No, they have some space in between. So the water molecules are actually in motion. In chemical kinetics, you have come across that. They are in motion because they are not tightly packed. There are spaces in between. Now, this space in between can accommodate air and any gas and any other thing. And so, it is this space in between that help for solutes to be dissolved in solvents. Now, if you dissolve salt in water or sugar in water, when the salt is ionized, the ions of the salt will now find their way in between the molecules of water in that cup of water. So you now see that the salt is dissolved. The same thing for sugar. When you dissolve sugar in water, the molecules of sugar now exist, occupy the spaces in between the molecules of water. And for the fact that the molecules of sugar is very tiny, you no longer see, then we say sugar is being dissolved in water. So this is how it exists. Now you can see the X represents, let me, this will be H, will be water. Now the H here refers to as the water molecules, while the S is the solute, which is the salt or the sugar being dissolved. What actually happens, you see the X in between the water molecules. That is how the solutes being dissolved are being accommodated in the solvents. That is how dissolution takes place, and we have solution. And thank you for watching. Have a time